Hello YouTube. So I have this Hewlett-Packard 3478 multimeter here. I believe I've shown this to you in a previous video about the value of older voltage references. So since I did that, I got some eyeballs in detail on stuff inside of it and realized there's some things that need servicing. I put some research time into that, and it turns out pretty much any 3478A will need this service unless it's already been done, or you're feeling gambly. I'll show you what I mean. So, first things first, we'll take it apart. This is one of the older versions that has the pre 34401A style case. So what you need to do is there's two slide out brackets on the sides, and then you can take off the top and bottom, and it's just one screw piece. Oh, and in true Dave EEV blog style, I lucked out with these, but the 3478As are very much don't turn it on, take it apart. So yeah, if you turn these on without checking or servicing them first, you are gambling with it going bang and making an atrocious smell. Be aware. So this is one I've already taken apart and looked inside. I've already cleaned this one, so we'll be skipping the cleaning portion. That's just something I do for everything I service. We can pause there. So, in here, now this will show up better. We have a few things to take care of. Right here, we have the RAM battery that holds the cal data. So you want to check that, and if it checks good, you almost certainly still want to replace it. So check here. See if I'm making proper contact. There we go. So it's getting 3.04 volts. And for the original batteries, I believe they are lithium sulfur dioxide chemistry, or some chemistry similar to that. I know it's lithium and sulfur is part of it. But that battery chemistry, 3 volts flat, is normal. However, the performance curve on these batteries is flat, 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 flat for years, nosedive, and then nothing. So, what we did checking the voltage doesn't really tell us how much life that has left. And so, unless it has a date written on it, which is what you should do when you replace it, it means that's up for replacement. Now, when you take this out, you're removing power from the cal RAM. So there's a couple things you can do. I'm planning on doing both. You can back up the cal data by GPIB, as long as you have any capability to interface by GPIB. There are more annoying ways to do it, like putting one of those chip clamps on it, but that's making more effort for yourself than you need to go through. Secondary method, which is a little more risky but is doable, and is one of the methods I'll be using after backing up, is you find a place that you can clamp onto, not the contacts because you have to solder and, desolder and remove that. But you want to find out where you can apply 3 volts from power supply to keep power to the RAM, and then leave that there while you desolder. Safety note for doing that: if you are using certain soldering stations and you have this connected to a power supply, check to find out if you have voltage potential between your power supply ground or negative and the tip of your soldering iron. I have an ISUN soldering station. It is the more expensive one with the toroidal transformer and doesn't have this issue, but the smaller, lighter ones that have the solid state switching power supplies do have the issue where they provide voltage at the tip. So if you have any path to ground, you're potentially, putting voltage into your board as you solder. A way around that is give the board battery by another battery, or give the board power by another battery. No path to ground, no shorting out. If there's voltage at the tip there and there's no path for it to go through, then you're fine. In my case, I always buy extras of whatever I'm going to put in if there's any chance I'm going to do the same repair multiple times, which I am because I already have 3 of these meters. So I just bought 5 of those batteries, and I'll just use alligator clips with on one end and the little HP tiny grabbers on the other to clip on there. So that's one issue. It's not the primary issue that you need to worry about. The main thing is right down there. So let's see if I can get a visual for you. Not sure how well that's going to show up because I'm looking at my phone screen right now. It's pretty small. But you might be able to see there's a crack in there. These are RIFA capacitors, R-I-F-A. And each of these 3478As has 4 of them. So there's 2 down there, and hiding under this GPIB cable, I guess I put away the flashlight a bit early. There's a couple more right there hiding under that GPIB ribbon cable. Now, the design of these RIFA capacitors, they are metal foil and they're encapsulated in epoxy. The problem is the epoxy degrades over time. Between hot and cold cycles and exposure to humid, dry, the epoxy cracks open, pretty cleanly cracks open, and gives atmosphere a direct path to intrude into the metal foil wrap. What that does is allow water from the air to gradually get inside that capacitor and short it out. This predominantly is only an issue for meters that have had cracking and have been stored unpowered for a while. The conditions they're stored in do matter. The humidity on average they're stored in does matter. But if they have that water intrusion, that humidity intrusion, they short out, they pop and burn out, and the burning of that metal foil and the decades-old epoxy, I have heard described as the electronic version of Strom something. I don't know how to pronounce it. Look up fermented rotted fish in a tin. It's this Norwegian specialty, I think. It's some Nordic country. I can only assume they invented it to torture themselves for no apparent reason. But they have fish. They'll put it in a tin without taking preservation methods to allow it to rot. And it'll rot and ferment. And the tin will actually bulge out from the decomp gases, and they consider it a delicacy. There are multiple hilarious stories of it exploding on airplanes during transport. It's not allowed to be transported by air anymore, I believe. And the smell just being incredibly horrible. Anyway, I have heard that the smell of those capacitors exploding and burning out is equivalent of that on the bad scale. So do yourself a favor. You don't need to experience it. Just take the internet's word for it. Or if you're going to intentionally make yourself suffer, take this outside. Plug it in and test it outside, not indoors. You don't need to suffer like that. All right, so moving on. To go further from here, to take this out, let's see. So we have the push rod for power right there. Let's see. And it looks like it's one of these situations where it'll slide out. Because we do need to pull the board. Well, it's easier to pull the board to get access to the capacitors under there. So, these will pop off. You don't necessarily need to, I believe. I think this will just take the feet off with the bottom plate. Yeah, it does. Oh, hello, Foofy. Yeah. Who's a pretty cat? Yes, you're very pretty. Here, you can have the chair. All right. I'm going to pause for a second and look this over. Okay, we're recording. Yes, we're still recording. Good. So, looking it over, I'm going to try. You want to do these things with the least disassembly and least effort possible to make things kinder on your future self when you go to reassembly. Unless you do need to go further, but we'll see. It looks like we have 3 screws right there that will allow us to detach this. I'm not sure if that's a filter, like power filter capacitor, or I don't think that's the voltage reference. I mean, that right there and the little ceramic heater thing is the voltage reference, so I don't know. Capacitor, probably. I could be wrong. I'm definitely capable of being wrong. So we have a few screws. We can take this whole plate off, and this plate holds this power section. So we want to take off the power button first. So let me see what's. Oops, sorry about that. Let's see. Let's get a little light. that is working. That's probably the better pry bar. Okay, so that works. So what I'm doing right there is there's a slot you can get into right there. And you just put something in there and pry a little bit while pulling this. Ah, okay. So push it in position, and that gives you a little more room to work with. There we go. So that popped out. And now, let's turn that off. Now we should be able to pop that rod off. But you want to be careful and gentle with it. And try to brace something against it so that you're not damaging it. Either the rod or the power button. Alright, so right now I got it off. I had to push it a little bit further to get it clear, and then I used the hook of this. Dental tools are great for electronics, to support the back side of the power switch so that I wasn't putting sideways force on the power switch as I pushed that rod down and it popped out. And then the rod just slides out. You kind of have to curve finagle it as you pull it out, and then it's out and out of the way. Just remember, well, you'll want to reassemble at least that much before you power it on, but just remember that if you did it like that, the power switch is on the on position. All right. Something else you'll want to do, pictures, pictures, pictures. You can never have too many documentation pictures. Like right here, we are probably going to be pulling these connections. It does look like they are not soldered. They are secured by pins. So we have brown, then orange, then red, and we'll be pulling those. Now, fortunately, this is from the old school, and it does actually say there red and then orange and then brown, which is great for reassembly in this case. But in general, it's good practice. Get pictures as you start pulling things apart, as you start pulling connectors, so that your future self, whether an hour later or a month later, can look at those pictures and go, oh, cool, that's exactly where that goes. And then there's no ambiguity and no, crap, how did this plug in? And is this a rare enough piece of equipment that I can't find pictures of it anywhere on the internet to find out for sure? So it's just a annoyance and headache saving measure. I just went to sit down. Hey, pretty. Who's a filthy chair thief? Who's gotten so used to getting away with everything because of how pretty he is? You have, you little jerk. But I mean, come on, guys. Look at this. Look at that. Damn it, cat. Well, there's nothing we can do about that, so we're just gonna do the rest of this repair standing or crouch down. The cat has spoken. Okay, now, for these, I'm trying to pull them out, wiggling. They're not exactly wanting to come out. And I certainly don't want to strip the wire out of that little connector and make more work for myself. So, we want something strong enough to pull it, but that won't damage it. What I like to use often in this situation is small Knipex pliers wrench. It's because these jaws are very soft and smooth. You can get like plastic caps to make them even softer and less marring, but they're very smooth. There's no serrations, no gripping, and it stays perfectly parallel. So you don't have this like one pinch point that'll crush a connector. You still have to be pretty gentle. You can't exert a huge amount of force, but it's great at spreading out that force so that you're not going to crush something. And then what I did there, what you don't want to do is grab and pull with this hand, or not just like that. So I had this gripped, and I had my hand under it, and I had the back of my wrist touching here. So then, with it gripped just enough that it wouldn't slip out, I levered this hand up slowly to pop it off. You don't want a situation where you're pull, resistance, suddenly free, yank, and you rip the wire away. So this method works pretty well. Only goes up as far as you want. No sudden fly away or rip away. And there we go. Okay, so we got those disconnected. I don't believe there's any solder connections that are going to be holding the power supply or the transformer on. It is soldered in place, so we can't remove this entirely. We're going to take it off and fold it over. And we also don't want to unscrew it from this vertical position because there's a fair amount of weight to that, and we don't want it falling and hitting other components or pulling on those wires. So this is the orientation we'll be unscrewing from. And thank you, old school Hewlett-Packard engineers. There is no bolt to catch from falling. The plate itself is threaded. The one disadvantage is if you screw up and strip those threads, it makes repair more difficult. But in terms of assembly and disassembly, so long as you're gentle, it's much less complicated. There are fewer parts. Fewer parts is fewer things to lose. And they even have a little bit of Loctite on it. Good on them. Electronics nowadays may be more advanced, like we may have more advanced components and certainly more advanced processing capability, but old school lab electronics, in terms of quality, that's undisputably where quality is. All right, So let's see if we can wiggle this around. It feels like it's still attached. So I'm going to eyeball this. Okay, so it's not just going to fall away on its own. I thought it was just screwed on with the 3 screws up here. It's what it looked like, but apparently there is more at play here. So I have my finger here, and when I pull up, I am watching the board flex a little bit, so we are still connected somewhere. I don't think it's that. Nope, it's not. Oh. Well, shoot. Maybe it is soldered in. Yeah. It is soldered into the board. It's screwed in place and soldered in place. Okay, so that makes this a little bit more complicated to remove, but still doable. Okay. So we can desolder the caps from there. Yeah, there's like C766 is one of them. And then right there, C765. So if we pull this, we can desolder those points, and we can get the caps out. And in theory, we can get the replacement caps back in. It's just really tight to put them in there. But it's probably going to be easier to do it that way than to like desolder this to get more space to access it. So that's probably what we're going to do. Yeah, this will be one of those things where you have to resolder one at a time in a specific order. Like that one in back, that's right down there. That'll have to be the first one in. It'll have to be like positioned by tweezers and maybe a little bit of sticky tack shoved down there to hold things in place while you turn it upside down and do the soldering. I think that's what we're going to do. Yeah. So in that case, we can go ahead and put these screws back in if we're not going to be disassembling that. And given the issues of we don't want to strip threads, so we need to be gentle, same screw going back into the same hole it came out of, even though they are supposedly identically threaded screws. You're always going to have less chance of something going wrong if you put the same screw back in its thread as it came from. And just feel gently for resistance. There should be little to none at first, and because there's a little bit of Loctite on there, then you'll start to feel resistance. But it's a matter of kind of feel to know the difference, and if it looks like it's proceeding in straight or if it looks like it's slightly angled, to know the difference between the resistance felt by Loctite residue and the resistance of I'm trying to cross thread something. Oh, and how I saw that they soldered this on, it's hard to get eyes this way, so you can get eyes on it if you look through it through here with a flashlight, and that's where I saw that it has direct solder joins from the transformer into the board. So now let's go ahead and pull this plate. I don't know if it's just this or it might be these two as well. We want to save the washer with the screw. Okay, it was just that one screw. And then it's not a big deal right now. There's very few screws taken out. Again, this thing is from the era of quality. Like, these are retained screws. They have a little kind of C-clip on it. Really well done. It also means that when you unscrew this, you're using like a screw thread drive to pull the initial out and push the initial or the last bit of in. So if there's any bit of stick, you have a lot of mechanical advantage. Really well thought out mechanical design. But yeah, this is one way to help make sure you know where your stuff comes from, where it goes to. If you have a lot more screws, I've previously gone over taking a piece of cardboard and then in a way that kind of mimics a mini version of your board, just stab the screws into the cardboard so they don't roll away anywhere. It stays in place pretty well. So now we're going to proceed to desoldering. Now, this was made quite a while ago. We can actually tell. So Hewlett-Packard and Agilent equipment have the year of manufacture built into the serial number. The first two numbers are the number of years after 1960. So this has a serial number starting in 23. This was made in 1983. So yeah, this is like 42 years old, and that means the solder is from 42 years ago. So when desoldering, if you're trying to get old solder to come off, it can be kind of a pain in the ass. And the trick to dealing with that is don't go straight to desoldering. First, you warm up your soldering iron, you wet it with a little bit of new solder, and you melt that new solder in to the joins you want to remove. The melted liquids or liquid fresh solder makes it a lot easier, even easier than straight flux, to transfer that heat into that joint or join. Your new solder melts, mixes with the old, and then it is much easier to either wick away that solder join or to use a desoldering tool and pull it away by vacuum. So, my desoldering setup, well, my fume extraction setup is a little bit awkward. Let's make a little bit of room. There's my janky soldering hose. I actually do have the 3 1/4, or no, 2 3/4 inch lock line hose, but in terms of bench space, I find it's easier just to store this underneath, so they don't have something permanently arced over like an elephant nose hanging over my desk and being in the way of stuff. It's less convenient when I actually go to desolder or solder, but yeah. Foofy. Foofy, I'm sorry. I do want my share for this, you beautiful jackass. Hey there. Yeah, I want my chair back. Who's so pretty? Yeah. Who likes ear rubbing? Yeah. Oh, who really likes ear rubbing? Yeah. Okay, I've paid you. Fuck off. Hey, don't hiss at me. You can't keep my chair. When I'm soldering, I kick the cats out. Come on. Come on. I love those cats so much. All right. So, let's get our solder. A little bit of leaded solder, Kester 44. Let's get the station turned on. And Safety first. Alright, so I have put sound suppression on this thing, so hopefully it's not going to be too loud through the mic. Okay, so we want here and here. So let's go ahead and add a little bit of solder first. Not much, just a little. Alright. And I believe I put the Heiko as switch 3. Yep. I'm not sure I'm getting vacuum. Oh, okay, it had to power up first. Alright, so. Alright, we got 2 of the solder joints pretty well, but not fully. So we're going to need to like manually pop them out. Let's turn off the vacuum. Right now what I'm doing is just trying to break the little bit remaining solder out of the via that it's stuck in, so that these will pop out. Preferably without putting too much stress on the board or randomly melting stuff. It doesn't look like I melted anything. All right, so that's 2 of them. Now let's see if we can pop them out. Alright, so that's still pretty stuck in. What I'm going to try here is I have this spudger kind of wedged in here. Oh, no, it's popping out. We got that one. Of course, you have to be careful how you grab it because the epoxy is just like old, cracked, and ready to break away. So it's not a great way to grab onto it. So we're going to try to just push. Looks like that one's all the way through. All right, we're just gonna wiggle at it. There we go. So that is the orientation it came out in. And here you can get a good look at how cracked it is. It's literally just completely open. Like there's, yeah, you can see it there. So this is one of the 22 nanofarad. And just make sure we're replacing that. These are Y2 safety capacitors, and you do want to make sure to replace them with the same rating, not just the same capacitance value, but also Y2 rated. Or actually, these are before Y2 existed. They are just Y rated. If you can see that. Yeah, 22 nanofarad Y. So Y is redundant, Y2 is the standard. So this is the replacement part from DigiKey. This is properly rated, 22 nanofarad and Y2 safety capacitor. I got like 20 of them. You just want to make sure that the legs are the same span apart and the cap's the same physical size. Let's make it easier on yourself. And that's what's going to go in a replacement once we have the rest of them out. So let's see about the next one's going to be more of a pain because it's, let's give you a view if we can. It's down behind those wires, like behind this. You can see it's hard to see. It's in between that switch and that supply right there. So it'd be interesting to see if we can get our how do we want to do this? Might be able to get a dental pick in there. And I've removed enough of the solder that I believe I can just wiggle it to break away. So you don't want to scratch the circuit board, so use soft, not sharp. And let's see. Okay, it's pretty flush with the board, so we want to try to push on these leads and give us some room. So I'm going to turn the vacuum back on. Safety first. So what I did there is, instead of the hole, I just put the side and touched it to the lead and pushed, letting heat transfer until it loosened that solder, and then it popped down. So the end of the lead is now not sticking up through the via, it's flush with the circuit board. And that'll give us some room to move. So that went fairly easy. Now let's see if we can get in there. Oh yeah, that's pretty loose. There's always a need for a different kind of tweezer. Okay. And there we have the other one. Also cracked. So that line in the center is crack. Sorry. Yeah. So I'm going to double check. I'll double check on the data sheet, but I believe these are non-polar, like no plus or minus. So it doesn't matter like if you, or which orientation you put them in. But if you're unsure and it's a capacitor that, it's connected to mains voltage, double check. So we have half of them disconnected. For the ones under the GPIB cable, we should be able to unscrew these little nuts here. I don't think I have the right size nut driver handy. Yeah, I'd have to get it somewhere. Screw removal pliers will be fine. Let's be gentle in our grip and not bite into it. Okay, it doesn't want to respond to gentle. So these will be non-marring. Yep, that works. Oh, these do have nuts. Okay. Yeah. So this GPIB cable, it hooks on with a kind of pinned dip assembly there. So unscrewing and just moving this out of the side by here is going to give you far less headaches than potentially bending a pin from an old style dip socket that's been plugged in for 40 years. I've seen someone else do, or pictures of their project of one of these, and they did bend a pin, and I mean, you have to use force to get these old styles back in for those dip sockets. So once it's bent, you're in for an unhappy time trying to get that back in without damaging it further or snapping it. Okay, so let's grab hold of this nut on the last bit of unscrewing. Let's repeat the procedure here. Yeah, let's see if we can. Yep, that works. Not quite finger loose yet. Maybe now? Yes. Okay. So it doesn't buy us a lot of room, but it is enough. Now you can see right down there, those are the other two capacitors. And just for reference, if I hold it up like this, that is the proper orientation to be able to read the writing on them. They are 1000 puff, or 1000 picofarad. And then, helpfully, they are labeled on the board. They are Charlie 721 and Charlie 720. So, same thing here. We'll turn our vacuum back on. We'll get a little bit of fresh solder mixed and melted in, and then we'll desolder. Safety on. Looks like the first one still needs a little more. Okay. Yeah, that first solder joint is still a little bit intact. I think we can push the rest through. We're going to use that same push method with the tip of the Heiko, or the side of the tip. We've got the majority of the solder removed, so we're not as worried anymore about anything coming off. Yep, that popped. Let's clean that a bit. That one does not want to go. That one did. Yeah, that one is... I want to be careful to not damage the pad. I mean, you don't want to put too much heat time on that. Alright, so we're going to give another try to put a little more... Like, we got surface layer solder on that pad out, but there's the stuff that's inside the via. So we're going to try mixing in a little bit more fresh solder and then repeat with the vacuum. So, this back on. And the difference between this on when I was doing the soldering and the vacuum, and then after the vacuum was sucked away and I was trying to get the last little bit, typically the metal in the solder isn't what splatters, it's the flux that's going to make splatter. So when you have that initial flux there, that's the majority of the reason why you want to shield yourself from splatter there. That did it. And in this case, the capacitor just fell through. I heard that happen. So we're going to pick this up. There's our 1000 puff Y-rated capacitor. The other one, as long as we can reach it okay, we should be able to just wiggle out. Yep. Barely took any effort. This one doesn't look so bad. It looks almost intact. But, I mean, you saw the others, how they were cracked, so... RIFA caps are always presumed to be just imminent failure. Alright, so I'm going to double check, well, I'm going to wash hands out, then I'm going to double check the data sheet on those caps, make triple sure that they are non-polar. I'm 95% sure, but you know, you don't make more work for yourself. Be back in a bit. Oh, and when I said wash out, literally just wash hands. Even though I'm not currently planning on going and like eating or drinking something, it's easiest if you build proper safety habits. So you don't want to get flux residue and lead residue, you know, ingested. Same thing as you don't want to breathe it in. So you just make a habit. After you're soldering and you're stepping away from the station, first thing you do, wash hands. Okay, we double checked. It might actually be on here. Oh, okay, that's fair then. Yeah, because it said 1.5 kilovolts DC. So let's take you over to the screen. So there's one of the parts. Is this? That's the 1,000 picofarad, so it's the different one. But yeah, write down where we are. There it is. Voltage rating AC. So it has an AC rating, so yeah, confirmed not polar. Let's go and double check the other one, because you're never an idiot for double checking something just to make sure it won't blow up. Yep, there's the 22 puff and AC voltage rating. So yeah, non-polar. No special orientation or polarity they need to be put in with. So we will get those put in, and then we'll move on to CMOS. I just realized I said CMOS, but I'm used to like motherboard, battery preserving data, CMOS. No, Cal data. Cal data. We're going to check something else first, just because we can. Let's get the right leads out. Not those. There we go. So we have new capacitors that we're putting in. They are, I mean, these are noise suppression and filter capacitors, essentially. But still, it behooves us to check on them. DigiKey is very reliable, but stuff happens. It's not like DigiKey has the time to spot check literally every part that flows through them. I reasonably expect that there's going to be no problems, but we have an LCR meter. It's a quick check. Yep. So let's get a couple of these out. These are the 22s. Yeah, these are the 22 nanofarad. And the adjuvant says about 18 2/3 nanofarad. It's close enough. Especially when it's just in a filter roll. Also, we didn't let the adjuvant have any warm-up time at all, so yeah, that's reasonable. Call that a pass. $18.8, that's fine. They are also in spec. It's a 20% spec, so yeah, doubly fine. So those are perfectly okay to use. Let's grab a couple of the 22, or the 1000 puff. And yeah, 99 floating nanofarad, or 0.99x nanofarad. 1000 picofarad. Other one. $963 picofarad. That's fine. Completely fine. Now, just out of curiosity, what value does these have? Uh, 1.22 nanofarad. So a little over, but within spec. .26 nanofarad. 29 nanofarad. 29 nanofarad. They weren't too far off. Yeah. And the failure with those isn't like the value going wonky. It's them becoming explodium and then very, very smelly. So, all right. That's good. So, let's see. I have stuff I have to take care of in 11 minutes. I think we're going to call it here for this video. I'm going to make it a multi-part. You saw the locations, you saw the desoldering. There's not a whole lot of trick to putting the new components back in. Take some of that sticky tack that you use to put stuff on walls, and you can put these into place and put a bit of that on top of it and shove it next to something to keep them in place, and that'll just hold them in position when you flip the board over to solder them, and then you can just take tweezers and pull the sticky tack off. It's a common trick for these kind of tight space situations. Very appropriate for this scenario. So, yeah, the location, getting those out, the values, and the Y2 safety rating, that was the important part. And how to maneuver to get there, and little tricks for, adding solder. Okay, I'm going to call that good for now. I will resume basically with another video. I don't know if I'm going to bother recording and showing putting those in. I think I've described that pretty well. But we will want to get saving the calibration data, and then we'll want to help everyone figure out and have reference for where to hook up your 3-volt source for when you desolder that battery to not lose your cal data, so you don't have to reload it by GPIB. All right, see you guys. Once again, this is for the Hewlett-Packard 3478A. Beautiful instrument.